Good afternoon. Let's talk about probability in chapter 3. Sometimes this can be a tough subject, so I'm going to try to break it down into many different videos to help you. So for 3.1, we're going to talk about terminology. Right? Probability is a measure that's associated with how certain we are with outcomes of an experiment or an activity. You would know probability more of what's your probability or your odds that you're going to win the lottery. And that's one way that we can think about it. So if you're trying to play Mega Millions and the odds that you buy one ticket that you'll win is very, very low. So an experiment is a planned operation carried out under controlled conditions. If the result is not predetermined, then that experiment is said to be a chance experiment. It's kind of like trying to win the lottery. If you're having an experiment where you buy a ticket to see if you win the lottery or not, you can or you might not. The odds are that you wouldn't, but that's an experiment. Another example is flipping a coin twice. And a result from an experiment is called the outcome. And that just means what happened once the experiment has concluded. An event is a combination of the outcomes. Uppercase letters like A and B represent events. For example, if the experiment is to flip one coin, event A might be getting more than one head, so the probability of event A is written by capital P with parentheses of A. The sample space of an experiment is the set of all possible outcomes. There's 3 ways to represent a sample space. It's to list the possible outcomes, it's to create a tree diagram, or to create a Venn diagram. The uppercase letter S is used to denote the sample space. For example, if you flip a coin, your sample space is S equals H and T, where H is heads and T is tails, and that's the outcomes. The probability of any outcome is a long-term relative frequency of that outcome. Probabilities are between 0 and 1. So that means 0 and 1 and all the numbers between those values. You cannot have a negative probability. There's not a negative 0.10% chance it's going to rain. You'll never have one. So the probability of an event equaling 0 means that the event A can never happen. The probability of event A equaling 1 means it's going to happen and it always happens. So the probability of event A equals 0.5 means it could occur or it might not occur. So for example, if you flip a coin repeatedly from 20 to 2,000 to 20,000 times, the relative frequency of the head approaches 0.5 is the probability of the head. And what that means is if I flip a coin 20 times, I might get heads 13 times and tails 7. If I go to 2,000, it might be closer to 11 heads and 9 tails. If I keep flipping that coin 20,000 times, the probability I'm going to get heads is 0.5 because it's 0.5 to get heads, 0.5 to get tails. So the larger your number of experiments or the times that you complete an experiment, the closer that it's going to get to its true probability. Equally likely means that each outcome of an experiment occurs with an equal probability. So think about having a die where you have a 6-sided dice. So each of these sides has an equally likely probability of occurring. Same things with a coin. It's equally likely that you'll have a head or a tail. And it's like if you guessed on a true-false question on an exam, you have a 50-50 shot of getting the answer right. It's equally likely. So to calculate the probability of an event where all the outcomes in a sample space are equally likely, count the number of outcomes for event A and then divide by the total number of outcomes in a sample space. For example, if you toss a fair dime and a fair nickel, the sample space would be heads on the nickel and the dime, tails on the dime, head on the nickels, head on the dime, tails on the nickels, or tail on the nickel and tail on the dime, where T is tails and H is heads. So This sample space had 4 outcomes. A is I want to do the event of getting one head. There are 2 of those outcomes that meet that condition, head, tail, and tail, head. So the probability that event A will occur is 2 over 4, or 0.5. The important characteristics of probability experiment is known as the law of large numbers. We saw that in chapter 2, because it says that as the number of repetitions for an experiment increases, the relative frequency obtained in the experiment tends to be closer and closer to the theoretical probability. We saw that with means. Remember, if I took a mean of a small sample, it might not be like the population. But if I keep taking larger and larger samples, that sample mean will become like the population mean. This is the same theory, it's just we're using it now with probabilities. It's the thing that I said with tossing a head and a tail coin. The more tosses I do, the more it's going to get to its true probability. Even though outcomes don't happen according to a set pattern or order, the long-term observed relative frequency will approach the theoretical probability. We sometimes use empirical instead of observed. It's important to realize that in most situations, the outcome are not equally likely. A coin or die may be unfair or may be biased.